Do you love math? If you do love math, I suggest to go to www.mrmathinc.net or YouTube Mr. Ing today. Very easy and compatible to work with.
Hey math lovers, let's go over 14.5 quiz number 8, April 8, 2022. Mr. Roberts likes to assign homework based on chance. We've got 3 greens, 8 marbles that are green, 3 blue, and 9 that are white. So that gives me out of 20. Select a green marble. So that would be 8 out of 20. And you can reduce that. Okay, I've done it again, right? So 2/5 is our answer. Blue marble, you have 3 out of 20. White marble, you have 9 out of 20. And when it says white or green, that means the probability of white, which is 9 out of 20, plus, the word or means plus, green, so that would be 8 out of 20, which gives us 17 out of 20, which is an option you guys cannot see. So I'm just going to write 17 out of 20. That's a 17. Let's try to make that more clear. 17. And not green. So green plus no green, or probability of not green, is equal to 1. So if you subtract the probability of green, you're going to get no green equals 1 minus green, which is called the complement. So 1 minus the probability of green, which is 8 out of 20. This will become 20 out of 20, so 12 out of 20, or 2 times 6, 2 times 10, I did it again, and that'll give you 3/5. 3/5 is your answer for the probability of not green. Question number 2, match a series with a total number of possible events. And so your 2 categories, no you don't have it. Flipping a coin and tossing. So this is just means the coin has heads or tails, and then a dice has 6 choices. So, alright, flipping 2 coins at once. So you have 2 choices, and then 2 choices for the second coin. So this is the first, and this is the second. So 2 times 2 would give us 4. We're doing this because they're independent events. Choosing a shirt and a pants to wear from 3 jeans. So that's the shirt. And then the pants, you have 3 options. So, whoops, that's a 2 times 3 gives us 6. And the possible letters, if you select 1 from the word terms. Terms has 5 letters, so you have 5 choices there. So 12, 4, 6, and 5. Question number 3. After watching and recording the outcomes of colored spinner, Dwayne has to calculate the following probabilities for each of the colors. The results are shown. So we don't actually have the spinner itself, and we cannot say that they're equal. All we can say is that we have the experimental probability. In the experiment, he's actually just recording his results. So, based on Dwayne's records, how many times would you expect the spinner to land on of each cover for the next 200 spins? So, you just have your number times your probability, which is, in this case, if we did green, that would be 0.16 times, actually it's backwards, 200 is your end value, times 0.16, and this would give us 32. And then you can just go down here and mark it at 32. And then we have red, same thing, 200 times 0.23, and this would give us 46. Something like that, color it in. And then we have yellow times 0.40, this would give us 80. Something around there. And then blue, you have 21. Put that in your calculator, I think it's 42. Question number 4, spinner is evenly divided into 8 sections. So the spinner, we're going to draw one. And I'm going to label it. Number is evenly numbered. And then a standard die. So this one, I'm drawing my 3-dimensional one, but it has 6 sides. Okay. If the spinner is spun and the standardized ties, what's probably that both the spinner and the die will land on a prime number? So prime has to be a number that's greater than 1, and then the other multiple or factor is itself and 1. Okay, so for example, 2 is a prime number because the only 2 numbers that multiply are 2 times 1. Now it has to be greater than 1, that's why I'm not selecting 1. 3 matches, 4 is 2 times 2, so is not a prime number, 5 is. So we have 3 out of 6 numbers here. Spinner, I've got 2, 3, 5, and 7. So we have 4 out of 8 here. This would give us 12 out of 48. And 12 times 1, that is 48. And 12 times 4, so my answer is going to be 1/4. I'm multiplying these because they're independent. Show your answer as a shaded fraction of the circle. So 1/4 is this portion here. Number 5, if A and B are independent events where probability of not A, so that means not A is equal to 0.6, probability of B is 0.3, then find the probability of B given A. So this is called conditional probability. And in our conditional probability, we need a formula. So the conditional formula probability is equal to the probability that A and B happens over given probability that A happens. Let's make these capitals. And just to review, this is the intersection of A and B, which can also be the same thing as probability of A times B. Okay, so remember, probability of A plus the probability that it's not A is equal to 1. So if you have 0.6, this one has to be 0.4. And then the probability of B is just 0.3. And I'm just left with 0.3 as my answer, which is C.
Lunchbox contains 3 kinds of sandwiches, and every time you draw one of them, you randomly and you eat it. So that's kind of like without replacement. Because then if you're like, oh, what's the probability of getting a second sandwich? Maybe it's a certain meat you want, like turkey, and you already ate one, that's changed, right? There's 3 sandwiches in the first time, and then only 2 sandwiches in the second time. And that was it. Hopefully that was helpful for you guys. See you later. Bye.
2 plus 2 is 4, minus 1, that's 3 quick maths. Everyday man's in the class, doing problems. See that problem board, that problem is easy, thanks to Mr. Ing.